All right, everybody, welcome back. This is the second video on sinusoidal graphs. And this one, I'm feeling a little weird. I'm going to try and do it all on Desmos because I have only one plan, one goal for this video is I want you to be able to look at the A, the B, the C, and the D and see what effect it has on our graph. Okay. If you need this graph or this copy, email me or you have access. I've probably emailed it to you several times. And it's the only thing that's different is it's just set up with the numbers across the bottom here. Because if you just, I think if you try this on just a regular Desmos, you just open Desmos and type that in, it's probably going to go like 1, 2, 3, 4, 5 across the bottom. And it's not going to be much fun. All right, so I have turned on my sine graph. You can see here, all I care, like right now, sine graph. And you can see that it is a periodic function. Remember, periodic function means it repeats over and over again. We want to start, and I just want to remind you, blue looks pretty right now. We are using this. Oops. That is our regular sine graph. Yeah, I was just thinking I wanted to change graphs, but I think this will do. You know what? That's horrible. Let's clear that. I can't draw very well. Let me just add a little graph down here to the bottom. Y equals sine x and whoopsies. Okay, so now we can see. Stop. Oh, I'm kind of excited. I can move that up so we can see everything at once. I really want you to begin with to just concentrate on this. So this is what our normal standard sine graph. There's my roller coaster. You're used to the roller coaster. Okay. So the first thing we're going to play with is the A out in front. And A, I like this one, stands for amplitude. So when you got your graph, A should have been set to 1. But as I move this, and I make it to 2, this blue line, that's where we started. So you can see what's happened is the maximum got bigger and the minimum got bigger. Now, I just think of it as the graph got taller. And not only did it get taller, what's really cool, if this is 2 over here, this now has an amplitude of 2. Remember, we have our middle here, our midline, and the amplitude went up to 2. All right, so now it's time for your imagination. If we take the amplitude and instead of A being 2, I'm going to move it up and I'm going to make it 3. Is that what you thought? Yeah, this really isn't. It's going to keep growing. So the bigger I make A, the taller my graph is going to be. It doesn't one period, so one cycle of the roller coaster, it isn't getting any longer or shorter. It's just getting taller. And I can make it all the way up to 10. Okay, cool. Yeah, if I make it smaller. Okay, good. And it originally was sitting at 1. Right down there. Oops, a little bit more. There. So you can see now the red one is actually right underneath that blue one. But now what I want you to do is I can go lower. What do you think is going to happen? I feel like Dora the Explorer or one of those kid shows. What do you think is going to happen, guys? Here we go. As this gets smaller, you can see my graph is actually flattening out. So my, let me just zoom in and you can maybe see a little bit better, right? So if I make that, let's make it a half. My amplitude is now a half. Next question. What do you think is going to happen when it goes to 0? It's going flatter and flatter and flatter. Well, how flat can you get? Boom. I mean, that's not really fair to call that a sinusoidal graph, because if you put a 0 out front, pretty much everything else disappears. Okay, so the bigger A is, the higher the graph. But wait, there's more, my friends. Not only can it go flat, but if you think about the pattern, now what? Now what's going to happen? Well, look at that. If I make A equal to -1, my graph now goes downhill first and then uphill. So when A is negative, your graph is, it's flipped, it's reversed. I don't know how you want to say that. So remember, our sine normally goes up first and then goes down. So now we're messing with it. It goes down first and then up. It's kind of like flipped, as if there was a mirror right here along that midline. But the cool part is the rest of it still applies. So if I make this bigger and bigger and bigger, it just goes more and more negative. And it will tell me how many spaces to count from my midline. So if this is -4, you know, it tells me I'm going to, you know what? It tells me I'm going to go down first. So 1, 2, 3, 4. And then we're going to go up. Okay. Whereas if I make it +4, you go up first, 1, 2, 3, 4. But you're always counting from that midline. That's what your amplitude does. I would strongly suggest you find the email, open the email, play with the email until you're comfy with this. All right, so A, to make it all nice and back to normal, was 1. All right, now we're going to start with B. And we said when B isn't there, it's 1. So that's why it's starting out here. So here we have our beautiful standard graph. And B is equal to 1. So now look what happens when I make B equal to 2. So our regular graph is the blue one. Our red graph is the change that I made. And you can see it got, I think of it as squishing the graph. Here, let me show you. If I go to 3 or, well, let's go 4, right? One period is that much. You go up the hill and you come back up. So instead of our nice, stately, long graph all the way to 360, it actually does it a lot faster. So the bigger B is, the squishier my graph gets. And I can squish it all the way up to 10. I could go bigger, but that's good enough. Okay. So let's make a conjecture. We haven't done that for a long time. Let's make a conjecture. I'm going to go to 1, and it'll match pretty. What happens when I go less than 1? So as it got bigger, my graph got squishy. So if my number gets smaller, my graph should do the opposite. It should expand. All right, now that's hard to see. Let me just zoom out. That should be enough. Okay. I'm going to go back to 1, all matchy-matchy, and see one cycle, boom, there. And actually, I'll go bigger first. Okay, so you can see the cycles as B is bigger than 1. One period is faster. So up the roller coaster, down to the middle again, you get way more of them. If we go this way and make B less than 1, let's make it 0.5. That should make the math pretty easy. Oops. There. If you trace the red one, you can see I go up the hill, I go down the hill. It's a pretty mellow roller coaster. Oopsies. And it takes all the way up to 720. So when B is less than 1, your graph gets longer. That's all you really want to know. But, because, I'm that person. Let me do this. All right, so if we go to 1, it takes a cycle to get 360. If I set B to 2, look what happens by the time we get to 360. You go, well, I can zoom in too. There's 1 period. Oops, 2 periods. So when B is 2, I get 2 periods with 360. If I set it to 4, I get to go 1 cycle, 2 cycles, 3 cycles, 4 cycles. So that B actually tells me how many cycles you get by the time you get to 360. What you really need, but honestly, what you need to know is that when you mess around with B, the length, the period of a cycle changes. And when B is big, it gets much smaller. If B is small, it actually gets bigger. I'll show you the 0.5 now. Maybe, yeah, it'll still work. Whoops, not 0.7. Hold on, I'll get there. There. All right, so if I set it at 0.5, you can see that you get half a graph by the time you get to 360. And you have to go all the way to 720 to get the full period. Somebody today asked me, well, what happens if B goes negative? And I said, bad things happen. Well, truth is I couldn't remember. So as it gets getting longer and longer and longer, so if B is 0, we get that flat line again. No, okay. Shh, I'm never going to make B negative, but it looks like it just follows the same pattern. Don't tell me. Don't tell the rest of them. All right, let's put B back to 1. So we will do a summary after. A summary. All right, so C, I'm going to have to zoom in to show you this because it's pretty subtle. I want you to watch. Okay, back up again. All right, so here is my complete cycle. I'm starting at 0 and I end at 360. If I make C equal to 10, well, I think I'm going to have to adjust that. Oh, I can. Let's make it equal. Whoopsies. Hello. From 0. There we go. To, let's say, 90. Okay. I don't know. I'm just going to pick 5. So now, how do I get back? Oh, no. And click up. There we go. Okay. So now, if C is 10, so put C back to 0. See, everything's all pretty and matchy. Now, as I start to move C, you can see, if we think of this as the start of my graph, it's moving. It's not getting any, the curves are still matching, right? They're not compressing like or expanding it. They were with B. They're just literally, I'm taking it and it just scooting down. So if I go all the way to 90, you can see now we're starting at 90. So what do you need to know about the C? That is going to mess and change your start and your end point. So for one complete cycle, move the graph over. Okay, we have C equal to 90. So instead of starting at 0 and finishing at 360 where it's supposed to do, it's now starting at 90 and it's finishing at 450. But if you take 0 and you add 90, you get 90. You take 360 and you add 90, you get 450. So it's not squishy or expanded, it's just shifted. And that's called horizontal translation. Okay, so quick review. A, changed how high it was. B, squishy, expanded. C, horizontal shift, moving stuff back and forth. Don't even worry about which direction. You just got to know that if there's a C value, it's going to shift stuff over. And it can be either the positive or negative direction. Okay, so we're going to put this back to 0. And the last thing is the D value. And the D one is pretty easy. All it does is it shifts where the midline is. So when D was 0, oops, right, here's the middle of my graph. Now when I make D equal to 1, you can see the graph is shifted up. Basically, every single point is just one unit, one box higher than it used to be. So I like to think of it in terms of the midline. And I always use the midline when I'm drawing my stuff, has moved up 1. If I make it, okay, so imagine if I make it D equal to 5. Where is it? There we go. Same thing, all we did is shift it up there. Cos graph is the sine graph is easy because your midline is also when you're starting. So if I look at this, I know I'm going to start up here at 5 and do my thing. But it's where the midline is. Ta-da! And there we go. Now you know more than you've ever wanted to know about the A, B, C, and D and what they do. But how about before we disappear, let's come back here. Yeah, there we go. All right, so summary. What do these things do? A is for amplitude. And it helps you find your max and your min. And it is I'm going to do this. It's a vertical measurement. Okay, so the A and the D, these kind of belong together. This gives you your midline. Or if I get all mathy, it should be vertical translation. Sorry, that was not helpful. Okay, vertical translation. This is going to be the middle. And it too is a vertical measurement that we have to worry about. These guys are horizontal measurements. B both of them are going to change how long a period is. So either it's going to take your graph and make it super duper long, or it's going to take your graph and it's going to be like super, super short. So that's expanding, that's compressing. And the C, and again, that's horizontal changes. The C part, this is going to mess around with the start and end. And again, that's going to be a horizontal measurement. All right, there is your, whoopsies. There is your summary. Oh, I forgot, this is called horizontal translation. I'm not completely depending on you to remember this horizontal and vertical translation. If you remember that C changes where it starts and ends, that's perfect. That's all I need. All righty. There's the end of the video. Have a lovely evening.